Hello, welcome to everyone in this video. This is lecture number 2 on nanomaterials and application. Today I want to discuss about the synthesis of nanostructure material, where we will be discuss that the top down and bottom up approach, then photolithography, then ball milling, then gas phase condensation, then vacuum deposition, then physical vapor deposition, then thermal evaporation, then electron beam evaporation, then pulse laser deposition, then chemical vapor deposition, then molecular beam epitaxy growth of quantum dot, chemical synthesis, chemical bath deposition, electro deposition, spray pyrolysis, hydrothermal synthesis, solvent synthesis, preparation through colloidal method. So these are the synthesis method of the nanostructure material. You can see in the previous lecture we discussed about the nanoscale system. We covered this chapter 1, this portion 1. Today want to cover this portion 2, and in upcoming session we will be covered portion 3, 4, 5 and 6 also. Let's start. The main approach, the two different approach to synthesize the nanomaterial is the top down approach and the bottom up approach. Top down means you have a bulk material, and if you etched this material and makes the nanoparticle is known as top down. That is a bulk into the nano-sized. But bottom up approach is the atoms or molecules are accumulated and makes the nanoparticles. So this is from big to small, and this is from small to big. Okay, so a bulk material is taken and machined is to modify into the desired shape and product is the top down approach, whereas the build something from the basic material is the bottom up approach. For example, top-down approach lithography, etching, ball milling, ion implantation. Bottom-up approach physical and chemical vapor diffusion, solvent technique, epitaxial growth. So this is the example of the top-down and bottom-up approach. Next thing is the difference is that the top-down approach is manufacturing started from the large structure and become small, whereas in bottom-up approach starting building blocks and smaller than the final product. This is from small to large product. Top-down approach produce structure with perfect shape and edge, and bottom-up approach surface is not perfect. The accuracy in the top-down approach is higher compared to the bottom-up approach, and the certain amount of wastage of material in top-down approach due to etching and etc. So wastage is the greater in top-down approach. The example is the photolithography, which is the top-down approach, that is the bulk material change into the nanostructure material. Here photo means light and litho means stone and graphy means write. That means we write on the stone using light is the photolithography. The step is like that. You have a clean silicon wafer or any wafer, have a coating a photoresist into oven, you will be that, and using a mask, if you UV radiated, these are the masked here, and this photo material are eliminated. Now if you etched, this region will be etched, so if you remove the photo resist material, you will be get final this type of structure. This can be positive photo resist material or negative. Positive means under UV light this is eliminated, and negative means these are not eliminated, where in the dark portion all are eliminated. This is the basic difference of photo positive and negative photo resist. Okay, the steps is written here, which are discussed here. These steps are written in the language here. That is the clearing or wafer, photoresist coating, then photo positive photoresist, negative, and apply photoresist, then soft breaking, and then expressing mask arrangement, development, and backing. Okay. The advantage of photolithography is the versatile method. It is a versatile method and suitable for mass production. For fabrication of high density and large array size material, this this process used to analyze the neutrophils which are in an important part of the immunity system, and for integrated circuit this is very useful, and for printing electronic board also this is useful. The disadvantage is that this is expensive and need clean room with the light, dim light, which prevent UV radiation, and the surface property can be controlled and long time. So these are the advantage, and this is the advantage of the photolithography. Then the important synthesis method is the ball milling method. This is also top-down approach. Actually, this is a cylinder type system, and there is a axis rod, and there is some ball. So this is like a blender system. And if you gives the bulk material, and if you rotate this cylinder, this collision with this ball, this crystal makes small size and make the nano particle. Okay, this is a hollow cylinder filled with the metallic or ceramic or rubber balls, and balls have the different diameter because they are for big size, and collision with the small one will be get smaller size. So occupy 30 to 50% of cylindrical volume, and inner surface of the cylinder is coated with an absorption resistant material. Principle is that the ball milling landing bulk material is the impact and attenuation, that is the friction. This is the basic principle. The material blending the occur during the rotation of cylinder. There are three types of mode, that is the cascade mode motion, rolling of the gliding ball but without flighting, that is just roll, not flight. Mixed mode, partially rolling and partially flight, and waterfall mode, that is the flying on the gliding ball. So these are the this can be rolled just on the surface of this cylinder. This is the cascade mode mode motion. But when these balls are flight, then this is called waterfall mode, and their mixture is known as the mixed mode. And milling rate, that is the how these particles melt and from the small size, the rate is proportional to like that rm mole to the power half rho m rp by rm. Okay, where is written rm is the radius of mill, that is the radius of cylinder, and rp is the radius of particle, rm is the radius of milling medium, density of milling medium. Okay, medium means which balls inside the uh, cylinder. The advantage is very fine powder can produce from this ball bearing method, and this is suitable for milling of toxic material, used for continuous operation, and used in milling of highly abrasive material. And disadvantage is that contamination may occur due to wear or tear of balls. The balls within this cylinder can wear and tear, so which may arise the contamination in this cylinder. And high machine noise level, relatively long time of milling, and difficult to clean the machine after use. So these are the disadvantage, and this is the advantage of ball milling method. Now the method is the gas phase condensation. Actually, the synthesis method have three method, that is the solid phase, liquid phase, and gas phase. And solid phase known actually the surface growth under the vacuum. This is the solid phase method, and then the liquid phase method, and another is the gas phase method. That means in the gaseous form condensed, and from the thin film nanoparticle, etc. etc. Okay. You can see there is a evaporation, that is the material which want to make thin film, they are evaporate, and there is a liquid nitrogen chamber. So these evaporation are condensed here and make the flames. So this is the gas phase condensation, and this chamber is evacuated using pump, because if don't evacuate this system, then the air molecules can impurity with this pure material. So to reduce the impurity, you need to vacuum this chamber up to 10 to the power minus 7 torr. Okay. So from at the first you need to vacuum this chamber, then fill the chamber with the inert gas such that it cannot inacted with this evaporated material. The inert gas cannot react with this material, so we use the inert gas and with a pressure like that 10 to the minus 3 torr. Actually, you need to uh, optimize the pressure because at high pressure the particle formation is required and low pressure prevent the elongation. So this optimized pressure is required to get in thin film. Okay, and metal evaporation by heater and vapor condensed the liquid nitrogen, which we just discussed. And the parameter which control the quality of shape and size of the nanoparticles or the nanomaterial or the thin film are that the vapor concentration, temperature, pressure, melting point of the metal. That is the concentration of vapor which are available with the system, then the temperature of the system and the pressure of the system and the melting point of the metal which are used. So these factors actually control the quality of shape and the size of the nanoparticle. The advantage of gas phase method is that is the good control on size, shape and composition. Then continuous process, both thin film and nanoparticle can form using this method. Ideal for the metal nanoparticle and the highest purity compared to the liquid and solid phase. The compared to the other two phase, this is the highest purity. And composite nanomaterial can form and used for large scale production. The disadvantage is like that slow process, the process is very slow. Aggregation of the particle prevent and the pressure adjustment is tricky job. So this is the important things, that is the pressure must be adjusted at a particular value such that this type of structure or the nanomaterial can be formed. So this pressure adjustment is a tricky job, which is the disadvantage. The special arrangement required to collect nano powder. So there are the disadvantage of this system of this synthesis process. The application of the gas phase condensation is that suitable for the preparation of the magnetic nanoparticle of cobalt, then widely used in the production of ultra-fine powders for use in catalyst and optical device, used for synthesis of nanoparticle for gas sensing application. Vacuum deposition, then the important thing, deposition process is the vacuum deposition. That means deposition in vacuum system. Actually, this is the surface deposition. Deposition on a substrate is the vacuum deposition, and this is the layer by layer deposition you can make. And source material in a vapor state via condensation, chemical reaction make forms, and this vacuum deposition can physical vapor deposition and chemical vapor deposition. In physical vapor deposition, vapor control without the chemical changing. That means the composition of this material does not change in physical vapor deposition. But in chemical vapor deposition, the composition of this material, chemical composition of the material can be changed. Principle is the vaporization of atom or molecule and deposition on the substrate. An advantage is the reduce particle density and enhance the mean free path, and contamination is low pressure plasma environment and control gas and vapor composition. Mass flow control the composition. So this is the basic advantages. Physical vapor deposition, that is in which there are no change in chemical composition. Objective is that the transfer atom from a source material to the substrate in a controlled manner. Example is the thermal evaporation and the sputtering. Thermal evaporation is like that the material is evaporated using a heater. Then sputtering means the argon plus are collide with this target and make the molecules and which are deposited on substrate. Then pulse laser deposition is like that. Instead of argon plus, the laser light are incident on target and make these molecules which are deposited on substrate. Then electron beam evaporation, that means instead of laser you eject the electron minus as from the electron gun, which also make the molecules which are deposited and make the thin film nanostructure. Then ion implantation, that means ion are eject here, and so sputtering is one of the ion implantation because this is also an ion. The first, the common example of PVD, that is the physical vapor diffusion, is the thermal evaporation system. You can see there is a heater. First, at the first, this chamber is evacuated by this pump. Then, at this region, just heater is on. This is melt, and this vapor material deposition on the substrate, and they are certainly used to control the deposition. Okay, so material heated and vaporized, deposited on substrate, and pressure of the chamber is low. For such, mean path is high, such that a collision will be low. And crystal motion on the nano substrate to record the quality and rate of deposition. Use is in the photovoltaic anti-reflection coating electrode in the solar cell. That means during making a solar cell, you need to electrode to get the output voltage is the use. Advantage is the simplest and economically among all physical vapor deposition technique. Solid material of any shape can used as source material, and deposition rate is very high and change of demand of the substrate during this deposition. And disadvantages like that, the required high temperature and the required ultra high vacuum, right? Due to high deposition rate, simply crystallinity is the low. Next is the electron beam evaporation. That is, instead of the heating, you can vaporize this material using the electron gun. This electron gun, this high energy electron are converted this material from solid to vaporized. This is also physical vapor deposition. This is control of our deposition rate. This can be controlled using this electron gun. The kinetic energy of electron converted into heat and melt the material and evaporate. Advantage, capable to heat a much higher temperature compared to the heater, and deposition can better monitor. So the deposition with better monitor, and for any material which can be evaporate, can evaporate and make thin film using electron beam evaporation. Next is pulse laser deposition, that is the laser light instead of electron gun you used here, and the target is there, so you can get multi-layer deposition in from on the surface. So purely is used for that. Advantage is the thickness composition can be controlled and large pressure range obtain precise control over the growth rate in the PL leaf. Disadvantage is like that laser ablation is high forward direction, that is this is along that direction, so it's non-uniform. Okay, so at a particular direction is ejected, and the ejected molecule are the uniform direction. So these are not this material are not uniform, which are formed in the substrate. Next is the chemical vapor deposition, that is the deposition of the solid material of chemical composition on the vapor phase, that is the composition, chemical composition can be changed. And this is the bottom up approach. You can see this is a chamber which you need to vacuum at first, then use the gas which you wants to deposit it here, and this capacitive arrangement, you can see these two plates are used as a capacitor, and apply a alternating voltage between this capacitor, and you will be get plasma due to this gas, and this plasma actually ionized gas, and these ions are deposited, and you finally obtain this thin film. This principle is like that: a vacuum the chamber, then gas inlet, and RF power produce the plasma, that is ionized gas, and film deposited. Okay, the advantage is like is that suitable for the large area thin film deposition. For large area thin film deposition, you can use this chemical vapor deposition, and used to deposit super quality film you can obtain, and widely used in the integrated circuit and the photovoltaic system. So this is the advantage of the chemical vapor diffusion. The disadvantage is the capacitively coupled CVD and okay, these are the different type of CVD. That is the capacitively coupled. This is the schematic diagram of capacitively coupled uh, CVD, chemical vapor diffusion. Then inductively coupled CVD, then epitaxy CVD, then photo CVD, then plasma acid CVD. So these are the common CVD system. There are also different CVD system. You can compare the PVD and the CVD, that is the physical vapor diffusion and chemical vapor diffusion. Physical vapor diffusion performed in solid state and chemical vapor diffusion in the gaseous state. There is no chemical reaction, there is chemical reaction occur, and this is diffused at relatively low temperature and this is reduced to high temperature. And this is low cost, this is high cost, and no varying flames produced, and varieties of flames can produced on CVD system. Molecular beam epitaxy growth of quantum dot. You know about the quantum dot, where the three-dimensionally confined with the geo-dimensional nanomaterial is the quantum dot, and which can be obtained using the molecular beam epitaxy. Where you can see these are the target and where the electron beam are ejected here, and they are make the layer by layer thin film. Okay. These are the different target. If suppose example this is a silicon, this is boron. So if you remove and use these two type of material, you can get the p type silicon. Okay, p type silicon test. So this is the molecular beam protection has the some advantage like that, that is a low control growth, low and control growth rate. That is the growth rate of this molecular beam protection is low and this can be controlled, whereas others in the not controllable. And this growth temperature is low and sequential deposition can done and ultra high pure material can obtain. So this is the advantage. Disadvantage is very complicated process and required ultra high vacuum and very expensive and growth rate is very low. So this is the advantage and this is the advantage disadvantage of molecular beam epitaxy. And the very low deposition rate with the layer by layer deposition helps to form quantum dot, because this quantum dot actually confined from the three direction. So this can be obtained. This type of nanostructure can be obtained from this molecular beam epitaxy method. So previously we discussed about the physical synthesis where the chemical process and physical process can be used, and this chemical synthesis like that the without this previous discussed machine, you can just chemical reaction can use to get the nanostructure. Okay, so previously we discussed about the physical method and now we want to control discuss about the chemical method to synthesis nanomaterial. The different type of chemical synthesis are like that. That is the corporation method, chemical reduction, electrochemical, microelectron pyrolysis, and photochemical, sonochemical, sol-gel, and solvothermal. So these are the process of the chemical synthesis. Number one is the chemical bath deposition is like that. This is the chemical bath where the stator is here, and within this beaker, this mixture is started here, and there is a substrate, glass substrate like that, are here. So they are thin film formed on this glass substrate. So this is the chemical bath deposition. That means the substrate holder bath on the chemical uh, test tube or the chamber and then deposited. Okay. Next is the electro deposition. That is the this is electro deposition voltmeter is like that. This is the cathode anode combination, and this is electrolytes element which are separated. The ions are separated and they are deposited on the positive and negative terminal of the battery. So by which the thin film can be obtained also. So the electrical current flows to the electrochemical cell and then deposited here, and the ions are separated here in this and then are deposited. Advantage is relatively cheap and fast process. This is a fast process, relatively cheap, but for due to fast process, it cannot control the thickness of the film, and the defects are be more. Okay, and then conductivity is low of this material. So this is the basic advantage and disadvantage of electro deposition. Next is pyrolysis is like that. Suppose you have a substrate and there is a heater, and within a nozzle, if you make the solution of nanoparticle, if you make the solution to produce the nanoparticle and then spray on the substrate and heating in the combination process, these thin film are formed. Okay, the steps is layer written here, that is precursor, solution, composition, then aerosol generation of the transport, and then synthesis. The advantage is a extremely easy technique and low cost, does not require high purity chemical, and the vacuum is not required. For dense and porous film, for multi-layer film, and use in glass industry on the solution. And disadvantage is like that the impurity and non-uniform thickness are obtained in paper. Next is the hydrothermal synthesis is like that. You need to a autoclave in which the chemical composition is written here, and then it is annealed, that is heated. You will be get the thin film. This is bottom up approach, and water placed within this autoclave in two part. There is a transmitting pressure throughout the medium. The throughout the medium pressure will be the same due to water, and the nano powder will be formed. Three methods of the hydrothermal synthesis are the temperature difference technique, then the temperature reduction technique, then metastable phase technique. The advantage of this method is that suitable for the synthesis of nanomaterial which are not stable at the melting point. The nanoparticle with the high vapor pressure can be obtained. Minimum loss of material, then particle size can control, and then high production cost. So this is the advantage of this, and disadvantage is lesser control about the aggregation of nanoparticle, and high pressure vessel, and presence of the conservative uh, stir. So these are the disadvantage of this hydrothermal synthesis. Next is solvent synthesis. We know that is the, suppose this is a glass substrate and this is a precursor solution take with a dropper and drops on the and there is a spin coating, then oven, and then repeat this process. And there is another is deep coating. If you have the solution and just dip into the solution of this substrate, you will be get thin film on this substrate. Advantage of solvent method is that it is a simple method and require low temperature, reproducible. It is reproducible and high surface to volume ratio. Final production can obtain. Limitation or the disadvantage of solvent method is that is allow high purity raw material which are not cost effective compared to minimal based metal ion sources. Since it is a multi-step process, it requires regular monitoring. It is difficult to avoid age groups and restrictive porosity. So this is the limitation. And preparation through colloidal method. You know the colloidal that is the there is a fog is a colloidal, that is the condensed uh, material on the liquid phase material. That is ultra fine particle are suspended on the diffusing medium is known as colloidal solution. Air advantage is energy efficient and reproducible and the cost effective. These are the questions which are asked in 2022 and 2021. You need to, I think these two are 22. These two questions asked in 22. 21, and this 4 question asked in 22. Okay, so you need to solve this question. I think you can do this. If any anywhere you any problem, you must comment the order. So this is all about me. This is my contact detail. This is my YouTube channel detail. Go to this channel. You will get different videos, some mathematics like this session. If you learn something for this session, share this video to your friends. Either he or she also get benefit from the video. Subscribe channel if you need channel. Those already subscribed. Thanks for subscribe. Press the bell icon to get notification. Okay. So take care. We'll meet in the next video as soon as possible. Thank you.